everyone. Today we will continue with our chapter Gravitation. So our first topic in it is free fall. So what is free fall? When a body falls from a height towards the earth only under the influence of gravitational force with no other forces acting on it, the body is said to have a free fall. And the body having a free fall is called a freely falling body. Here you can see that these bodies are freely falling body. It has no force. Only the gravitational force is acting upon them. They are jumping from a height, but under the influence of gravitational force they are falling towards the earth and no other forces acting on them. Now let's see free fall of a coin and feather. Here in the image you can see that two tubes are taken and in one air is filled and in another vacuum is filled, and in it feather and a coin are dropped from same distance from this portion, and at what pace, at what force or at what velocity both the things fall is being recorded and the observation is taken. Now inertia plays an equally important role in this. And now what is inertia? Inertia is the resistance of any physical object to any change in its velocity. This includes the change to the object's speed or direction of motion. An aspect of this property is the tendency of the objects to keep moving in a straight line at constant speed when no force is acting upon them. Here you can see that when no force is acting, this both will fall at the same pace. But when vacuum is filled, then both this coin and feather will fall towards this portion at same speed because of the presence of vacuum. This concept of inertia is displayed in the vacuum tube as explains why even the coin has a greater force of gravity acting on it compared to the feather, the fall with the same acceleration. Here you can see that in this air, coin will fall faster and feather will fall afterwards. But in vacuum, both the things will fall at the same acceleration at the same pace in this tube. Now let's see acceleration due to gravity. What is it? Acceleration due to gravity is defined as the uniform acceleration produced in a freely falling body due to the gravitational force of the earth. Here you can see that this is denoted by small g. There is a difference between capital G and small g. This is known as acceleration due to gravitation, and that capital G was the gravitational constant. So always keep in mind both the symbols. Now the unit of this, SI unit of this is meter per second square. Now let's see how to calculate the value and its formula of acceleration due to gravity. From the second law of motion, the force is the product of mass and acceleration. We all know this thing. So F is equals to mg. Let this equation be number. Now, let the mass of the stone or any object thrown upwards be m. Here you can see that a ball is thrown upwards. We already know that there is an acceleration involved in falling object due to the gravitational force and is denoted by g. Here you can see that after going up to a certain height, then it will fall downwards. So, therefore, the force of the magnitude or the magnitude of the gravitational force F will be equal to the product of the mass and acceleration due to the gravitational force. That is, the equation will be F is equals to G m into m upon r square. You know this formula. So, from equation 1 and 2, we can say that mg is equals to G m into m upon d square or r square, whatever the distance you take, r or d. So here you can see that m and m can be cancelled out. So G is equals to G m upon d square. This is the formula to calculate the value of G. And here m is the mass of the earth and d is the distance between the object and the earth. Now let an object on or near the surface of the earth. Now let's assume there is an object on or near the surface of the earth. So how we will calculate the acceleration due to gravity for it? In it we will do nothing but change the distance as small, we had taken this small r or small d. Here we will take capital R. Here R is the radius of the earth and the distance between that object and the center of the earth. Here you can see that the distance in distance d in equation 3 in the previous equation will be equal to r, because here the distance would be measured between the object and the radius of the earth. Thus for the object on or near the surface of the earth, its formula for gravitation, acceleration due to gravitation, would be g is equals to g m upon r square, where r is the distance of the object from the center of the earth. See how we will calculate the value of g. To calculate the value of g, we should put the values of capital G, capital M and capital R in g is equals to g into m upon r square. Namely, we have the values as universal gravitational constant g is equals to 6.7 into 10 to the power minus 11 Newton meter square per kg square. And the value of mass of earth is 6 into 10 to the power 24 kg. And the radius of the earth is 6.4 into 10 to the power 6 meter. Now substituting these values, we will get the value of g as 6.7 into 10 to the power minus 11 Newton meter square per kg square into 6 into 10 to the power 24 kg upon 6.4 into 10 to the power 6 meter the whole square. Here only I have substituted these values. So we will get 9.8 meter per second square. Now, how we got the meter per second square when there is no here second square in this equation? So, here n is equals to kg meter per second square. So, here when I substitute kg meter per second square, here kg square, per kg square, and here kg square will become, so it would be cancelled out, and here 2 meters squares would be cancelled out. So, only remaining would be 1 meter and per second square. So, its value is 9.8 meter per second square. Thus, the value of acceleration due to gravitation of the earth is g is equals to 9.8 meter per second square. Let's see motion of objects under the influence of gravitational force of the earth. So, we know that when the value of g does not depend on the mass or the distance of an object, because the formula for small g is equals to capital G into m upon r square, where capital G is the gravitational constant, m is the mass of the earth, and r is the radius of the earth, which does not include any constant or any value of mass or distance of the object. Therefore, the acceleration of the force applied on the object would be same for all the objects. So, in case of uniform acceleration, we know that there are three equations of motion, which are also known as the laws of constant acceleration. Hence, these equations are used to derive the components like displacement, velocity, and time and acceleration. Therefore, they can only be applied when acceleration is constant and the motion is in a straight line. The three equations are. So from this para we can understand that when an object falls under the influence of gravitational force of the earth, it falls in the straight line and the acceleration is constant, because the only acceleration is because of the gravitational force of the earth. So the equations for the laws of constant acceleration are v is equals to u plus at, v square is equals to u square plus 2as, and s is equals to ut plus half at square, where s is the displacement, u is the initial velocity, v is the final velocity, a is acceleration, and t is time of motion. These equations are referred as SUVET. When you sometimes you have difficulty, learn these equation as this formula in this matter, SUVET. So it will be easy for you to remember. Now further. The equation for motions are as follows. Now, v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. We saw in the previous slides. So, now we here substitute a by g, because here we are taking the gravitational constant, because it is the moment of the object is under the influence of the gravitational force of the earth. So our equations will become V is equals to U plus GT. Here only I substituted G instead of A. S is equals to ut plus half gt square, and v square is equals to u square plus 2gs. Now these equations are for constant acceleration when an object falls from certain height. In this equation, initial velocity is u, final velocity is v, time taken is t, distance covered is s, and the value of g is taken as positive in this case because the object is moving towards the earth, and taken negative in case of object is thrown in opposite direction. So when an object when we throw it upwards, the value of g would become negative, and when it free falls on the surface of the earth, it would become positive. Let's see some example. A car falls off a ledge and drops to the ground in 0.5 seconds. Let g is equals to 10 meter per second square. For simplifying the calculation, we have taken g is equals to 10 meter per second square instead of 9.8 meter per second square. What we have to find out first, what is the speed on striking the ground? Second, what is its average speed during the 0.5 second? And third, how high is the ledge from the ground? Let's see how we will find these three asked questions. So the solution is, here we are given the time is half second, that is 0.5 second, and initial velocity is 0 because no force is applied, it directly falls from a ledge, and the acceleration due to gravity is 10 meter per second square. So now acceleration of the car is A is equals to 10 meter per second square because it is a free fall and falling downwards without any action on it. So it is plus 10 meter per second square. So first we have to find the speed. So V is equals to U plus AT, but here U is equals to 0. So we can directly write V is equals to AT. And now we are given A and T. So V is equals to 10 into 0.5 or half, so we will get 5 meter per second. Next we have to find average speed during the 0.5 second. So it's initial velocity plus final velocity divided by 2. So initial is 0 and final is 5. So divided by adding them and dividing them by 2, we will get 2.5 meter per seconds. Next is distance traveled. So s is equals to half at square because s is the distance. So s is equals to half at square. So half into a is 10 meter per second square and time is 0.5 second and the whole square. So it is half into 10 into 0.25 second square on 0.5 into 0.5 is 0.25 second square. So its answer is 1.25 meter. So the ledge is 1.25 meter above the ground. An object is thrown vertically upwards and rises to a height of 10 meter. Calculate the velocity with which the object was thrown upwards and second, the time taken by the object to reach the highest point. Let's see how we will find out. So, first of all, we will write what are the given things. So, the distance traveled is s is equals to 10 meter. The final velocity is 0 meter per second, and acceleration due to gravity is 9.8 meter per second square. But here as the object is thrown upward, so it would be negative. So here it will become minus 9.8 meter per second square. So first of all, to find the velocity, we will apply this formula, that is v square is equals to u square plus 2as. Now substituting the values, we will get 0 is equals to u square plus 2 into minus 9.8 meter per second square into 10 meter, which gives minus u square because taking u square on the LHS, which is equals to minus 2 into 9.8 into 10 meter square per second square, which gives the value of u as root of 196 meter per second because we took square on the RHS. So it becomes the root. So root of 2 into 9.8 into 10, which is 196. So it's root. So which gives the value of u as 14 meter per second. Second, we have to find the time taken. So v is equals to u plus 8. Now we know the initial velocity and final velocity and the acceleration of the objects. Substituting those value in this formula, we will get the time. So 0 is equals to 14 meter per second into 9.8 meter per second square plus t, which gives the value of t as 1.43 seconds. So the initial velocity u is equals to 14 meter per second and the time taken is t is equals to 1.3 seconds. Thank you, and if you have any doubt, comment in the comment section.